evening, and welcome back to another episode of Sleeping with the Dinosaurs. Tonight, we drift back in time to meet one of prehistory's most iconic and unmistakable giants, the Stegosaurus. With its towering backplates and fearsome spiked tail, it has captured imaginations for well over a century, standing as a strange and beautiful reminder of a world long past. As we explore its ancient life together, I invite you to settle in, relax, and let the distant echoes of the Jurassic fill your mind. Before we begin our journey, if you enjoy these quiet voyages into the age of dinosaurs, please take a moment to like this video and subscribe so you can join us again. And down in the comments, tell us, from where in the world are you listening to this episode tonight? Now close your eyes if you wish, and let the curtain of time draw back. Our story begins in a land both familiar and alien. Imagine, for a moment, the world as it was 150 million years ago. The air is warmer, thick with the scent of damp earth and the sweet, resinous aroma of towering conifers. The sky is a gentle wash of gold and rose as the early morning sun pushes over the horizon, spilling light across a landscape that feels at once wild and untouched. Rolling stretches of fern prairies sway gently in the breeze, their fronds beaded with dew. Giant cycads rise like green pillars, their crowns bursting with stiff palm-like leaves, while the shadows of ancient tree ferns stretch long across the soft soil. Somewhere in the distance, the slow, resonant calls of enormous sauropods drift through the mist, a reminder that this is a land ruled by giants. It is here, amid this living tapestry of the late Jurassic, that our eyes catch sight of something moving. At first, it's only the vaguest suggestion of shape, a slow, rhythmic shifting among the low ferns. But as the mist begins to part and the sun lifts higher, the creature takes form. A low, arched back sweeps forward into a small head that hovers just above the vegetation, while along its spine rises a strange and breathtaking display. A row of massive leaf-shaped plates that stand upright like the sails of some ancient ship. This is our first glimpse of a Stegosaurus. It moves with deliberate slowness, its hind legs longer than its forelegs, giving its body a gentle slope from tail to head. Each step is steady, almost cautious, pressing deep, rounded tracks into the damp earth. As the creature turns slightly, the sunlight catches the edges of those plates, making them glow as if lit from within. They are not smooth, but ridged and grooved, their surfaces bearing the subtle weathering of age and life in a wild land. No two are exactly alike. Some are broader, others taller, their arrangement alternating along the backbone like the teeth of some ancient comb. The Stegosaurus lowers its head to feed, plucking mouthfuls of soft ferns and horsetails with a beak that works like shears. The sound is almost inaudible, the gentle rasp of vegetation being snipped and swallowed. Its neck is short, so it must move its entire body rather than simply stretch its head, a slow rocking motion that makes the plate sway ever so slightly. Behind it, the tail sways with a weight and purpose all its own. The last four spikes jut outward at angles, each one perhaps 3 feet long, gleaming faintly in the morning light. These are not decorative, they are weapons, as much a part of this dinosaur's life as its legs or plates. They hang idle now, but the slow, careful movements of the tail speak of a creature well aware of their power. The ground beneath the Stegosaurus is soft with fallen needles, fern litter, and the compost of countless seasons. As it walks, small insects rise in a cloud around its feet. Somewhere nearby, a dragonfly the size of a man's hand darts through the humid air. The buzzing of cicada-like creatures blends with the distant calls of larger animals, creating an ever-present chorus of life. It is difficult to convey just how large the Stegosaurus is without standing next to it. This particular one stretches nearly 30 feet from its blunt snout to the tip of its spiked tail. At its tallest, where the plates rise high above the hips, it stands as tall as an average man. Its body is sheathed in thick, pebbled skin, the texture of weathered leather mottled in earthy browns and muted greens that help it blend into the forested edges of its home. The plates, however, are a striking contrast, perhaps a dusty red along their edges, fading to a pale, almost bone-like color near their base. As we watch, another shape stirs in the distance. A second Stegosaurus emerges from the morning haze. This one slightly smaller, perhaps a younger individual. It moves toward the first with slow confidence, and the two meet in a quiet ritual of recognition. They do not touch plates or tails, but instead circle one another briefly, snuffling at the ground and occasionally glancing up at the other. Their movements are unhurried and there is no sign of hostility, only a calm acceptance that they share this space. The air grows warmer as the sun climbs higher. Shadows shrink, and the sheen of dew vanishes from the vegetation. The stegosaurs wander toward a patch of softer ground near a shallow stream, where cycads cluster in dense stands. They feed together here, their tails occasionally swinging wide to swat away buzzing insects. Overhead, a pterosaur glides past, its wings flashing silver in the sun, before disappearing into the distant tree line. It is in these moments that the Stegosaurus seems less like a fossil from a museum display, and more like a living, breathing animal, one with its own quiet rhythm, attuned to the steady pulse of this Jurassic world. It does not rush, for there is no need. Its greatest threats are far off, and its massive bulk and defensive tail offer a certain security. Instead, it moves with the patience of something that has always known this land, that has walked these fern-filled valleys for generations. Every few minutes, the larger Stegosaurus lifts its head fully, nostrils flaring as it samples the air. Perhaps it is catching the scent of other herbivores, or maybe the faint, unsettling musk of a predator. The breeze shifts, and it lowers its head again, apparently satisfied, yet its tail sways a little more purposefully now, as though keeping its defenses limbered. A gentle rustling comes from the cycads, and a small reptile darts out, its long tail whipping behind it. It pauses, freezes in place for a heartbeat, then vanishes beneath the leaves once more. The stegosaurs do not react. Their attention remains fixed on their foraging. Still, the sudden movement is a reminder that this peaceful scene exists in a web of constant activity, from the tiniest insect to the largest predator. By midday, the air is thick and heavy, the kind of heat that makes the colors of the landscape seem richer. The plates along the Stegosaurus's back are flushed now, a deeper red than in the morning. Whether this is a trick of the light, a result of blood flowing near the surface to release heat, or simply the imagination, it adds another layer of mystery to this animal's design. Scientists have long debated their true purpose, but in this moment they seem both beautiful and functional. Nature's strange marriage of art and survival. The two stegosaurs wander slowly out of the clearing, moving toward a more shaded area where the canopy thickens. As they pass, they leave behind wide, deep tracks in the soft soil, impressions that under the right conditions could be preserved for millions of years, only to be discovered long after their species has vanished. The sight is humbling. Each step is both ordinary and monumental, a living mark in the deep story of Earth's past. As the sound of their footfalls fades into the forest, the light catches on the edge of a distant plate one last time, a brief glint of red and gold among the green. Then they are gone, swallowed by the trees and the haze of heat, leaving only the rustling of ferns and the faint whisper of the wind. The land settles back into its slow rhythm. The dragonfly returns to its perch. The cicadas sing on. Somewhere far away, a deep, resonant bellow rolls through the valley, the voice of another giant, perhaps an Apatosaurus, calling across the Jurassic plains. But for now, our focus shifts, following the Stegosaurus not just as a distant image, but as a subject of wonder and closer study. And so, with our first glimpse fading into memory, we step deeper into its world, ready to explore its strange and remarkable form in all its detail. The Stegosaurus is unlike any other creature in Earth's history. Its very outline is a contradiction, a low-slung body topped by an array of towering plates, ending in a tail armed with formidable spikes. It is a blend of elegance and menace, a living sculpture shaped by millions of years of evolution. To truly appreciate this dinosaur, we must slow our gaze, Let our eyes linger on each feature and understand how all these parts work together to create one of nature's most memorable designs. Begin with the plates, rising in two alternating rows from the base of the neck to the tip of the hips. They are not thin, flimsy structures, but massive sheets of bone. Some measure nearly 3 feet in height, shaped like elongated diamonds, their edges tapering into delicate points. Imagine standing beside one. The surface would not be smooth like polished stone, but rough and pitted, patterned with shallow grooves that may once have been pathways for blood vessels. In life, these plates were covered with a sheath of keratin, the same material found in the beak of a bird or the horns of a rhinoceros. This outer layer might have given them a slightly glossy finish in the sunlight, catching the eye even from a distance. The arrangement of these plates is as fascinating as their size. Rather than forming a single neat row along the back, they are staggered, alternating from side to side, creating a zigzag silhouette when seen from above. The effect is striking, especially when paired with the arch of the dinosaur's back. Some scientists believe this alternating pattern made the animal appear even larger and more imposing to predators. Others think it created a distinctive display for communication within the species, perhaps a way to signal health, maturity, or dominance. And then there is the matter of color. Fossilized plates cannot tell us their exact hue, but the possibilities are endless. Picture them as earthy browns and muted greens, blending with the surrounding foliage to hide from predators, or imagine them flushed with rusty reds or ochres, flaring into bright display during courtship or confrontation. If blood truly flowed close to the surface of the plates, then in moments of agitation or excitement, they might have changed shade slightly, just as the skin of certain modern reptiles deepens or lightens in response to mood. In the warm light of the Jurassic sun, this could have been a breathtaking sight. Below the plates, the body of the Stegosaurus tells a different story, one of grounded strength. The torso is deep and barrel-like, housing a vast digestive system needed to process its plant-based diet. The forelimbs are shorter than the hind limbs, giving the body its characteristic downward slope from hip to head. These legs are thick and columnar, built not for speed but for stability. Their sturdy construction allowed the animal to support its weight, estimated at around 7,000 pounds for a large adult, without strain. The head, by contrast, seems almost comically small compared to the rest of the body. It is narrow and wedge-shaped, with a beak at the front for clipping vegetation. Behind the beak are small, leaf-shaped teeth suited for stripping leaves from branches, but incapable of chewing in the way modern mammals do. Instead, food would have been swallowed in large chunks, to be ground up later in a muscular gizzard, much like in modern birds, aided by swallowed stones or gastroliths. The eyes are set on the sides of the head, giving the Stegosaurus a wide field of vision to scan for danger while grazing. Yet for all its grandeur, the Stegosaurus is perhaps most famous for what comes after the plates, the tail. Known to paleontologists and popular culture alike as the Thagomizer, a name coined humorously in a cartoon and later adopted in scientific writing. This tail bears 4 long, sharp spikes. Each spike could measure up to 3 feet in length, tapering to a lethal point. They are set in pairs slightly splayed to the sides, allowing for maximum coverage when swung. Fossil evidence tells us these spikes were not mere decoration. Some Allosaurus bones have been found with puncture wounds matching their shape and size, suggesting that the Stegosaurus was more than capable of defending itself with swift, powerful tail strikes. To picture this in motion, imagine a predator approaching from behind, its eyes fixed on what it believes to be slow, vulnerable prey. In an instant, the Stegosaurus pivots its rear half, the tail whipping through the air with surprising speed. The force is immense, enough to shatter bone or pierce deep into muscle. Even the most determined carnivore might think twice before risking another charge. The positioning of these defenses is itself a marvel, because the Stegosaurus's head was low and its body relatively inflexible. It could not easily bite or swipe at an attacker. Instead, evolution concentrated its most dangerous weapons at the opposite end, turning its rear half into a living fortress. This made sense in the predator-rich environments of the late Jurassic, where large theropods like Allosaurus and Ceratosaurus prowled the same landscapes. Every part of the Stegosaurus's anatomy seems to have been shaped by the pressures of survival in this ancient world. The plates, whether for display, temperature regulation, or intimidation, made it stand out visually. The heavy muscular body allowed it to travel slowly but steadily across vast distances in search of food. The spikes provided an unmistakable deterrent to would-be attackers. Even its relatively low stature had advantages. By keeping close to the ground, it could graze on a wide variety of low-growing plants without competition from taller browsers like the towering sauropods. And yet, it's important to remember that these features did not exist in isolation. A Stegosaurus was more than just a sum of plates and spikes. It was a living animal with instincts, behaviors, and roles in its ecosystem. Those plates may have caught the sunlight during a morning stroll, flashing as the animal passed through gaps in the trees. The spikes may have been used not only in defense but in ritualized displays between rivals, tails swinging wide in a slow, deliberate arc to warn an opponent without bloodshed. In the soft rains of a Jurassic afternoon, droplets may have run down the plates in thin rivulets, catching the glint of fading light as the animal grazed in peace. Standing close to such a creature, if we could, would have been humbling. The slow, deep breaths moving its massive chest, the faint rustle of its tail through the undergrowth, the subtle shifts of weight as it adjusted its footing. All of these details remind us that this was not a monster or a myth, but a real being that once lived and thrived. As the day in our imagined Jurassic landscape stretches on, the Stegosaurus moves steadily across the terrain. It is not a sprinter, but it is purposeful. Its plates sway gently with each step, their shadows dancing on the ground. The spikes of its tail sway too, like the pendulum of a great clock, marking time not in seconds but in the slow rhythm of a life attuned to ancient seasons. From a distance, the silhouette of the Stegosaurus against the horizon is unmistakable, a living emblem of prehistoric times, even millions of years later. Its form has the power to capture our imagination, to pull us into a world that feels both impossibly distant and vividly real. And so, having studied its form, we are ready to see how this extraordinary creature lived. Not just what it looked like, but how it passed its days in a world filled with both opportunity and danger. The sun has only just begun to rise over the Jurassic landscape, painting the horizon in deep bands of orange and gold. The air is warm and damp, carrying with it the earthy perfume of fern fronds and damp soil. Our Stegosaurus stands still in the shadow of a stand of cycads, its plates glowing softly as they catch the first rays of light. For a moment, the creature does not move. It simply breathes, its great barrel chest rising and falling in slow, steady rhythm. This is the calm at the threshold of the day, a pause before the slow cycle of feeding, moving, and surviving begins anew. The first act of the day is almost always the same. Feeding. The Stegosaurus lowers its head toward the undergrowth, its small, narrow snout moving with surprising precision as it selects the most tender ferns from the thicket. Its beak makes quick, efficient work of clipping fronds, the soft tearing sound almost lost beneath the distant rumbling calls of unseen sauropods. The teeth, small and leaf-shaped, shear through the plant matter, but do not chew it in the way mammals do. Instead, the leaves are swallowed in large pieces, destined for the great fermentation chamber of the gut. The morning is the most active part of the day. The heat is not yet oppressive, and the ground still carries the coolness of the night. Our Stegosaurus begins to move, pushing deeper into the fern-covered meadow. Each step leaves behind a deep, rounded print that may be filled with water before the day's end. The plates sway gently from side to side as it walks, a motion that seems almost lazy but is born from the slow, deliberate pace of a creature conserving its energy. This slow pace is not a sign of weakness. The Stegosaurus has no need to rush. With its formidable tail spikes, the Thagomizer, poised behind it like a line of polished spears, It is well defended against most threats, but the vigilance never fades. Every so often the animal stops and lifts its head, nostrils wide, scanning the air for the scent of danger. Its eyes, set on the sides of its small head, provide a wide field of vision capable of catching movement from nearly any direction. As the Stegosaurus moves along the meadow's edge, it comes across a cluster of horsetails growing in damp soil near a small stream. The plants sway in the morning breeze, their slender stalks tipped with cone-like structures heavy with spores. This is a favorite food, and the Stegosaurus steps carefully into the soft mud, lowering its head to strip the stalks with quick, precise bites. Its tongue, though not long like that of some modern herbivores, shifts the plants into place for cutting. The water nearby is shallow and slow-moving, dotted with floating mats of ancient algae. Our Stegosaurus wades in up to its ankles, the surface rippling around its legs. It lowers its head to drink, the motion slow and deliberate, sending rings of disturbance across the mirrored surface. From beneath the shadow of a submerged log, a small turtle-like reptile paddles away, avoiding the great tree-trunk-like legs, descending into its territory. By mid-morning, the light has grown harsher, filtering down through the tall, straight trunks of conifers and cycads. The forest hums with life. Dragonflies with wingspans as wide as a man's hand dart above the water, their glassy wings catching the sun. Somewhere in the canopy, a pterosaur lands heavily, its claws gripping a branch as it folds its leathery wings. The Stegosaurus pays them no mind. Its focus remains on the endless supply of plant matter surrounding it. Occasionally, it lifts its head to watch for movement among the trees. Though the morning is peaceful, danger is never far in the late Jurassic. Allosaurus, the dominant predator of this time and place, is more than capable of bringing down even a fully grown Stegosaurus if it can land the right bite. But the risk is greatest for the young or the old. Our Stegosaurus is in its prime, large, strong and armed, and would not be an easy target. Still, the flick of the tail from side to side is not just for balance. It is a reminder, a constant readiness to defend. By midday, the heat becomes heavy and oppressive. The sun beats down on the plates, and here they may serve another purpose beyond display or intimidation. The alternating arrangement of the plates along the back allows air to flow between them, and if blood circulates through these bony sails, they might release excess heat into the air. This would be a welcome relief in the height of a Jurassic afternoon, when the ground radiates warmth and the air feels thick enough to drink. The Stegosaurus seeks shade, moving toward the denser forest along the base of a ridge. The canopy here blocks much of the direct sunlight, and the air is cooler. Shadows ripple across its back as it moves beneath the trees, the mottled pattern helping it blend into the dim light. Though its size makes true hiding impossible, the camouflage may still confuse a predator's eyes, making the outline of the plates less distinct at a distance. It rests here for a time, standing rather than lying down. For an animal of its size and build, rising from a fully prone position is slow and awkward. Better to doze lightly while on its feet, shifting weight from one leg to another as it rests its muscles. The forest around it buzzes with activity. Insects drone in the undergrowth. Somewhere to the east, the deep, resonant calls of a diplodocus roll across the land like a low wind through the trees. As the day progresses, the Stegosaurus resumes feeding, this time on the cycads and low-hanging branches of young conifers. It strips leaves with slow, deliberate bites, swallowing them whole. Each mouthful joins the steady fermenting mass within its gut, where colonies of microorganisms break down the tough plant fibers. This process is slow, meaning the animal must spend most of its waking hours feeding to maintain its bulk. Late in the afternoon, the Stegosaurus approaches an open stretch of grass-like plants, their stalks waving gently in the breeze. Here it is, joined by another of its kind, a slightly smaller individual, perhaps a female or a younger male. They keep a respectful distance, feeding side by side without interference. This is not a social species in the sense of coordinated group behavior. but it tolerates the company of its own kind when food is plentiful. The pair moves slowly across the plain, their plates casting long, strange shadows in the lowering sun. Every so often, one will pause to scan the horizon. Far to the west, dark shapes move along the edge of the trees, too distant to identify, but large enough to warrant attention. After a few minutes, the shapes disappear back into the shadows, and the feeding continues. As evening approaches, the heat begins to ease, replaced by a gentle cooling breeze from the higher ground. The Stegosaurus makes its way back toward the edge of the forest where it will spend the night. It does not build a nest or shelter. Its size and defenses are its security, but it chooses a place where the ground is soft and the vegetation is thick enough to conceal its outline. The light fades and the air fills with the chirping and croaking of prehistoric insects and amphibians. Somewhere in the darkness, a predator's call echoes low, throaty, and close enough to raise the hairs on the back of the neck. The Stegosaurus shifts slightly, positioning itself so that its head faces the sound, tail angled in the opposite direction. It waits perfectly still, muscles ready to act if the shadow in the night grows too bold. But the sound fades and the forest returns to its nightly rhythm. And so the day ends much as it began, in stillness, with the slow, deep breath of a creature that has endured and adapted to the challenges of its world. Tomorrow will bring the same cycle, feeding, moving, resting, and watching. In the great sweep of Earth's history, it is an unremarkable day, yet each of these days, repeated over millions of years, is what allowed the Stegosaurus to thrive, to leave its mark not only on the land but in the fossil record, a quiet chapter in the story of life that would endure long after it was gone. When one first lays eyes upon the Stegosaurus, it is impossible not to be drawn to the spectacular array of plates that march along its spine, towering, alternating, and unlike anything seen in the animal kingdom today. These bony structures have inspired fascination and debate since their discovery. Their sheer size and peculiar shape demand an explanation, and for over a century, paleontologists have wrestled with the question, what exactly were they for? Were they shields of protection, devices to regulate temperature, or did they serve a more social purpose, a prehistoric billboard broadcasting health, dominance, or readiness to mate? The earliest scientists who examined Stegosaurus remains assumed the plates were defensive armor. The reasoning was simple. In a world teeming with massive predators such as Allosaurus and Ceratosaurus, any large herbivore would benefit from natural protection. To the 19th century mind, the Stegosaurus's plates were an obvious barrier against bites and slashes, like the overlapping scutes of a crocodile or the armored panels of an ankylosaur. The very name Stegosaurus, meaning roofed lizard, reflects this thinking, as Othniel Charles Marsh, the paleontologist who first described the animal, believed the plates lay flat along the back like roof shingles. But as more complete fossils came to light, this interpretation began to falter. The plates were not positioned flat but upright, alternating along the spine. This arrangement left large gaps between them, hardly an impenetrable shield. Moreover, their thinness and internal structure did not seem suited to absorbing heavy blows. A predator's teeth or claws could easily slip between the plates to reach the softer flesh beneath, and even a direct hit might snap a plate clean off. The idea of defensive armor gave way to another possibility, that the plates functioned as a means of thermoregulation. This theory emerged in the mid-20th century, when scientists began to study the plate's internal anatomy in greater detail. They found a rich network of vascular canals, channels that might once have carried blood close to the surface. In this scenario, the plates would act much like the large ears of an African elephant, radiating excess heat on hot days or absorbing warmth from the sun on cool mornings. The alternating arrangement along the back could have allowed air to flow between them, increasing their efficiency as thermal fins. It is a compelling idea, especially when we consider the late Jurassic climate. While generally warm, temperatures could fluctuate between day and night, and an animal the size of Stegosaurus might benefit from a built-in heating and cooling system. Early mornings could see the dinosaur positioning itself broadside to the rising sun, plates angled to catch the maximum amount of heat, while in the heat of the day blood flow to the plates might increase, allowing heat to dissipate into passing breezes. Yet, thermoregulation may not tell the full story either. Even in modern animals that use parts of their body for heat exchange, those features often serve multiple purposes. An elephant's ears, for instance, are also used in displays to appear larger or more intimidating. This brings us to perhaps the most widely accepted modern interpretation. Display structures are common throughout the animal kingdom. From the colourful plumage of birds to the elaborate antlers of deer, these features often signal health, maturity, and genetic fitness. In this light, the Stegosaurus's plates might have functioned as a visual language, a large, well-arranged set of plates, free from damage or disease, could indicate a strong, healthy individual. The vascularization seen in the fossils hints at the possibility of color changes, much like the flushing skin of some reptiles and birds today. During mating season, blood flow to the plates might increase, intensifying their color to attract mates or warn rivals. The social display theory gains further weight when we consider that not all stegosaurs, the broader family of armored dinosaurs to which Stegosaurus belongs, had identical plates. Some, like Kentrosaurus, had smaller plates and more prominent spikes, suggesting that different species evolved different arrangements to suit their particular needs or environments. In Stegosaurus, the evolution of such large, upright plates may have been driven as much by visual impact as by any functional advantage in temperature regulation. Still, there is no reason the plates could not have served multiple purposes. Nature rarely wastes a structure entirely on one task if it can be used for several. A feature that evolved for display could also have been co-opted to help regulate temperature, and in a pinch, even thin plates might deflect a glancing blow from a predator. In this way, the Stegosaurus's plates could have been multifunctional, billboards, radiators, and partial shields all in one. The debate also extends to the arrangement of the plates. While the alternating pattern is well supported by fossil evidence, some early reconstructions depicted them in a single row down the spine. Others imagined them paired in symmetrical sets. The staggered arrangement, however, creates a more visually striking profile and may have been more effective for both display and thermoregulation. From a distance, this alternating row could give the illusion of an even larger animal, the plates breaking up its outline and making it harder for predators to judge its true size and shape. Imagining these plates in life is a fascinating exercise. Picture a fully grown Stegosaurus at dawn, standing in an open clearing. Its plates catch the golden light, their colors deepening as blood flows to their edges. A rival approaches, tail swaying slowly from side to side. The Stegosaurus arches its back, lifting its head just enough to tilt the plates toward its opponent, the sun glinting off their surfaces. No contact is made, no tail swings in anger, but the message is clear. This is my space. Move on. Or imagine a cooler Jurassic morning, mist rising from the ground as the Stegosaurus turns broadside to the sun, soaking in its warmth. The plates act like solar panels, drawing heat into the bloodstream, allowing the animal to become fully active more quickly. In a climate where nights could be cooler than the days, such an adaptation might be critical for survival. The conversation about the plates is far from over. Advances in technology, such as 3D modeling, histological analysis of bone, and comparisons with modern analogues, continue to shed new light on these structures. Some researchers have even proposed that the plates might have been used in species recognition, a way for Stegosaurus individuals to identify each other from a distance in a world filled with other large plant-eating dinosaurs. If so, the exact shape and arrangement of plates could have been as distinctive as the stripes of a zebra or the antlers of a deer. No matter which interpretation one favors, the plates remain a central part of what makes Stegosaurus so captivating. They are a reminder that evolution often produces solutions that are as beautiful as they are functional. Whether serving as shields, radiators, signals, or all of the above, they transform this already impressive animal into an icon, one whose silhouette is instantly recognizable even to those who know little about dinosaurs. And so, as we leave the debate behind for now, we turn our attention to another part of the Stegosaurus's anatomy, a feature far less flamboyant than the plates, but no less vital to its survival: its mouth and the steady, patient work of turning the Jurassic's endless greenery into the energy that kept this plated giant moving. The Stegosaurus, for all its grandeur in form and defense, was at heart a creature of the green world. It lived and breathed by the rhythm of its appetite, and the plants that carpeted the Jurassic landscape were both its lifeblood and its constant occupation. To imagine a day in the life of this great herbivore without focusing on its diet would be to miss the very foundation of its existence. Picture the late Jurassic vegetation, as far as the eye can see: endless ferns unfurling their delicate fronds, cycads rising like palm trees frozen in a strange prehistoric stillness, conifers stretching skyward in towering spires. Between them, low mats of mosses and horsetails cluster along streams and ponds, their segmented stems swaying in the breeze. Flowering plants have not yet evolved. The world is dominated by these ancient lineages, some of which are already hundreds of millions of years old. Our Stegosaurus moves slowly through this green expanse, its head never rising far above its shoulders. This is a grazer of the understory, a specialist in what grows within a few feet of the ground. Its narrow wedge-shaped skull is tipped with a beak, a structure of keratin like the bill of a bird, perfectly shaped for nipping and stripping leaves. Unlike the grinding teeth of a mammal, this beak and the small leaf-shaped teeth behind it are built for shearing rather than chewing. Once a mouthful of foliage is clipped, it is swallowed with little more than a cursory crush. This method of eating means that the Stegosaurus swallows much of its food in large pieces. Inside its massive body, an equally massive digestive system goes to work. In the absence of efficient chewing, the task of breaking down tough plant fibers falls to a long fermentation process, aided by a population of microorganisms that thrive within its gut. These microscopic partners turn the cellulose-rich leaves into digestible sugars and nutrients, producing gases and heat as byproducts, a slow, steady conversion of plant matter into the energy that fuels this lumbering giant. It's possible, perhaps even likely, that the Stegosaurus swallowed small stones known as gastroliths. These smooth, rounded pebbles, picked up from riverbeds or lake shores, would sit in the muscular part of the stomach and help grind plant material, much like the gizzard of a modern bird. The presence of gastroliths in other herbivorous dinosaurs supports this idea, though direct evidence in Stegosaurus is harder to confirm. Still, it's a fitting image, this great animal carefully selecting pebbles with the same deliberate motions it uses to pluck ferns. The plants of the Jurassic offered both abundance and challenge. Ferns, a staple for Stegosaurus, are rich in certain nutrients but lack others, requiring constant feeding to meet daily energy needs. Horsetails, with their silica-rich stems, would have been tougher to process, but they grow rapidly and in dense clusters, making them an appealing target for a hungry herbivore. Cycad leaves, though fibrous, may have been part of the diet as well, particularly the tender new growth. Conifer branches, especially from younger trees with low-hanging limbs, would have provided variety and possibly year-round food in seasons when other plants died back. Feeding was not a casual activity for Stegosaurus. It was the center of its day, an animal of its size, weighing up to 7,000 pounds, likely needed to consume hundreds of pounds of plant matter daily. This meant hours upon hours of steady browsing, interspersed with slow movements from one feeding patch to another. In this, the Stegosaurus's slow, deliberate pace was an advantage. Moving too quickly would only waste energy that could be conserved for digestion and defense. The act of feeding itself was a quiet ritual. The beak closes around a frond, the head pulls back with a soft snap of severed stems, and the frond vanishes into the small mouth. The eyes flicker to the sides, scanning for movement, while the neck subtly shifts to reach the next leaf. Every few minutes, the Stegosaurus straightens slightly, stretching to its modest full height to strip leaves from a low branch before returning to the more comfortable range of ground-level plants. There is a rhythm to this behavior, a pulse of activity that seems unhurried but is constant. In the cool of the morning, the Stegosaurus may move more frequently, covering more ground before the heat of the day slows its movements. By midday, it feeds in the shade, perhaps near a water source where lush plants grow even in the driest weeks. As evening approaches, it may range a bit farther again, stocking up on energy before settling in for the night. In feeding, the Stegosaurus was not alone. The late Jurassic was a time of herbivore abundance, and it shared its food sources with a variety of other plant-eating dinosaurs. Long-necked sauropods like Apatosaurus and Diplodocus grazed and browsed at different levels, their massive heads sweeping through tree canopies or stripping mid-level vegetation. Smaller ornithopods nibbled at low plants with quicker, more mobile feeding styles. This division of the plant world into feeding zones helped reduce direct competition, allowing these giants to coexist in overlapping territories. Still, there would have been moments of overlap, times when a group of sauropods moved through, stripping away the very plants a Stegosaurus had been working on. In these moments, the Stegosaurus might move on without confrontation, relying on the vast abundance of plants to find another patch. But if pressed too closely by another herbivore, it could turn slightly, tail swinging in a slow arc as a warning. Even in the plant-eating world, personal space mattered. While feeding, the Stegosaurus had to remain vigilant for predators. Its head-down posture left it vulnerable to ambush, and though its senses were tuned to detect danger, the best defense was often awareness. A sudden lift of the head, a stilling of the beak mid-bite, and a frozen stance could signal that the animal had caught the scent or sound of a carnivore. Only when it was satisfied that the threat was distant would it resume its quiet grazing. The plants themselves may have shaped the Stegosaurus's seasonal movements. In wetter months, lowland plains and floodplains would have been rich with growth, the ferns and horsetails thick and tender. In drier periods, the Stegosaurus might follow river corridors into higher ground or denser forests, where cycads and conifers provided a more reliable food source. These shifts would have taken place over miles, with the Stegosaurus moving slowly but steadily, always in search of the next patch of green. In thinking about its diet, it's worth remembering that the Stegosaurus was not simply a consumer of plants, but also a participant in the health of its ecosystem. By feeding, it pruned back certain species of plants, allowing others to flourish. It may have dispersed plant spores and seeds in its droppings, spreading vegetation across the landscape. Its sheer size and movement through the undergrowth would have created small clearings where sunlight reached the forest floor, encouraging the growth of new plants. And so the Stegosaurus's mouthfuls of ferns were part of a much larger cycle, one that connected the plants, the herbivores, and even the predators that relied on those herbivores for food. Each bite was a link in the chain, each slow step to the next feeding patch, a small act in the grand theatre of Jurassic life. From here, our journey into the life of Stegosaurus leads us not to its food, but to the world it shared, the other giants, the lurking hunters, and the living landscape that surrounded it. To understand this animal fully, we must see it not in isolation but in its proper place, among the company of dinosaurs that lived alongside it, in a world as rich and dangerous as any that has ever existed. The world of the Stegosaurus was not an empty stage where it wandered alone beneath the Jurassic sun. It was a living, breathing theatre of colossal creatures, each adapted to a niche in the great web of life. To picture the life of Stegosaurus without its neighbours would be like describing the ocean without mentioning its waves, incomplete and lacking the energy and tension that defined its reality. Imagine standing on a rise above a broad fern-covered valley. The air is warm and heavy, laced with the sweet, resinous scent of conifers. In the near distance, our Stegosaurus moves slowly along the edge of a stream, its plates glowing with a muted copper sheen in the late morning sun. But the eye is quickly drawn beyond it, to the shadows moving through the trees and the shapes towering on the horizon. This is the community of giants, and Stegosaurus is only one member of it. Perhaps the most imposing of its companions are the sauropods, the long-necked behemoths like Apatosaurus, Diplodocus and Brachiosaurus. These titans dwarf even the largest Stegosaurus. Apatosaurus, with its column-like legs and neck stretching high above the ground, moves with slow, sweeping steps, each one a quiet tremor beneath the soil. Diplodocus, long and slender, uses its whip-like tail to flick away the occasional insect or signal to a neighbor. Brachiosaurus, rarer in these parts, is a true skyscraper of the Jurassic, its head held high like the crown of a living tree, browsing at heights no other herbivore could reach. These enormous plant-eaters do not compete directly with Stegosaurus for food. Their sheer size grants them access to a vertical buffet, towering branches and leaves that our low-browsing Stegosaurus cannot reach. In turn, Stegosaurus's specialization for feeding on ferns, cycads, and low-hanging branches keeps it from stripping the canopy leaves that sustain the sauropods. Yet their coexistence is not without tension. When a herd of sauropods moves through, the ground trembles and the vegetation is scoured at every level. If a Stegosaurus happens to be feeding in their path, it may have to step aside, tail swaying defensively, until the living wall passes. Where there are great herds, there are great predators. For Stegosaurus, the chief threat comes from Allosaurus, a lithe, powerful carnivore with serrated teeth and long, grasping claws. Allosaurus is not as massive as a Stegosaurus in terms of sheer weight, but it is a formidable hunter, capable of using speed, agility, and coordinated attacks to bring down prey. Fossil evidence, puncture wounds in Allosaurus bones, suggests that these predators occasionally learned the hard way just how dangerous a Stegosaurus tail could be. But this danger did not make Stegosaurus immune. A distracted or injured individual, or a juvenile still growing into its plates and spikes, would have been a tempting target. Ceratosaurus also stalked the landscape, though perhaps preferring smaller prey. This predator, with its distinctive horn on the snout, may have been more of an opportunist, willing to scavenge when it could not hunt successfully. For a Stegosaurus, the sight or scent of either predator would have been cause for heightened vigilance, head lifting, nostrils flaring, tail swinging into a ready arc. And then there were the smaller, faster predators, the fleet-footed theropods whose names we may never know, darting in and out of the edges of the great herbivore herds. These hunters were too small to challenge a healthy adult Stegosaurus, but they might harry juveniles or take advantage of a weakened individual. In the great game of survival, no creature was entirely without risk. Not all neighbors were threats. Ornithopods, smaller two-legged plant-eaters like Camptosaurus, shared the low vegetation with Stegosaurus. Quick and nimble, these dinosaurs could dart away at the first sign of danger, perhaps alerting slower creatures to the approach of a predator. Some may have even trailed behind Stegosaurus deliberately, taking advantage of the plants it disturbed or the cover it provided. Their relationship was not cooperative in any conscious sense, but in the overlapping rhythms of their lives, they were part of the same mosaic. The landscape itself played a role in how these giants interacted. The open fern meadows were gathering places where different species might converge to feed in relative peace. Here, a Stegosaurus could graze within sight of a Diplodocus herd, both focused entirely on their own meals. The forest edges were more intimate spaces, where the shadows hid both food and danger. In these transitional zones, a Stegosaurus might be alone, or in the company of a few others of its kind, feeding quietly among the cycads. The floodplains and river corridors were vital arteries in this world, where lush vegetation thrived year-round and water drew creatures from miles around. In such places, encounters between species were inevitable. Picture a Stegosaurus drinking from a slow-moving river when a massive Apatosaurus herd arrives to cross. The smaller animal steps back, giving ground as the water churns beneath the weight of the giants. A few juvenile sauropods linger, their long necks craning curiously toward the plated stranger before hurrying to catch up with their mothers. Overhead, pterosaurs wheel in lazy arcs, their sharp eyes scanning the water for fish or small reptiles flushed out by the commotion. These interactions were not just chance meetings, they were the structure of the ecosystem. Each creature had its role, its niche carved by millions of years of adaptation. Stegosaurus's role was as a mid-level browser, large enough to deter most predators, but not so massive as to ignore them entirely. It was both a consumer and a shaper of the plant world, its grazing patterns influencing which plants dominated in certain areas. It was a neighbor to the sauropods, a wary observer of predators, and a quiet presence in the daily life of smaller herbivores. But living with giants also meant living in the shadow of change. A drought could tighten resources, forcing more overlap between species that normally avoided competition. In such times, even the usually calm relationships between herbivores might strain. Sauropods might wander farther, feeding on plants they normally ignored, while Stegosaurus might have to venture into less familiar territory in search of food. Predators, too, would adjust, taking advantage of weakened or isolated individuals. In the wet season, the opposite was true. Food was abundant, and the great herds spread out, the landscape alive with movement. Fern meadows waved in the breeze, cycads put out fresh fronds, and the rivers ran full and clean. In these months, the interactions between giants were more relaxed, the tension of survival softened by abundance. To live among these giants required more than physical adaptation. It required a kind of unspoken negotiation, a constant awareness of the movements and needs of others. The Stegosaurus did not think of this in any conscious way, of course. Its awareness was instinctual, shaped by the countless generations before it. The flick of a tail, the angle of a head, the sound of a distant bellow. These were the cues by which it measured its place in the ever-shifting patterns of the Jurassic world. And so, the Stegosaurus's days were not lived in solitude, but in the company of some of the largest and most remarkable creatures to ever walk the earth. Its world was one of shared spaces, overlapping needs, and a constant dance between cooperation and competition. From this crowded stage of giants, we turn now to one of the most distinctive and formidable tools the Stegosaurus carried into its daily life, a weapon that could turn the tide of any confrontation, and whose name has become almost as famous as the dinosaur itself, the Thagomizer. If the Stegosaurus were a fortress, its plates might be the high walls, visually impressive, perhaps even a deterrent, but the true defense, the weapon that could turn a predator's confidence into a fatal mistake, was the tail. At its end, 4 long spikes jutted outward like the tines of a deadly rake. This arrangement, both elegant and fearsome, is known to science and popular culture alike as the Thagomizer. The term Thagomizer has an unusual origin. It was not first coined in a paleontology journal, but in a 1982 cartoon by Gary Larson. In the comic, a caveman lecturer gestures toward a diagram of a Stegosaurus tail and tells his audience that the spikes are named after the late Thag Simmons. The joke caught on, and remarkably, scientists began to use it in informal conversation until it appeared in more formal writing. Today, while Thagomizer is not the official anatomical term, it is widely understood in both academic circles and by dinosaur enthusiasts around the world. No matter what name we give it, the Thagomizer is a masterpiece of defensive design. Each spike could reach 3 feet in length, thick at the base and tapering to a sharp point. They were not fixed in rigid alignment, but set slightly splayed apart, giving the tail a spread of lethal points that could cover a wide arc in a single swing. Fossil evidence shows that these spikes were anchored firmly into the tail's bony vertebrae, supported by heavy muscles capable of generating tremendous force. To picture the Thagomizer in action, imagine an Allosaurus, the dominant predator of Stegosaurus's world, stalking from the shadows. It circles, head low, testing the defenses. The Stegosaurus does not flee, its speed is limited, and running might only invite an attack from behind. Instead, it pivots its rear half, keeping the predator in sight while presenting the tail at an angle. The Thagomizer swings in a slow warning arc, the spikes glinting in the sunlight. This is not a bluff. With one powerful twist of its hips, the Stegosaurus could drive those spikes deep into the flesh of its attacker. We know this is more than theory because the fossil record bears scars of such encounters. One particularly striking specimen of an Allosaurus hip bone shows a puncture wound that fits perfectly with the size and shape of a Stegosaurus spike. The injury had begun to heal before the animal's death, proving that it had survived the encounter, but the damage must have been significant. Other bones show similar marks, evidence that the Thagomizer was not just for show, it was used and used effectively. The mechanics of wielding such a weapon are fascinating. The Stegosaurus's tail was not stiff like a beam. It was flexible, capable of lateral swings and sudden thrusts. Muscles along the base of the tail provided the torque, while tendons and ligaments kept the motion precise. The alternating plates along the back did not interfere with these movements. If anything, the animal's long, sloping body gave it an ideal pivot point to generate momentum. A full-force strike could shatter bone, tear muscle, and end a confrontation in an instant. But as with any weapon, there was strategy in its use. Striking required bringing the predator close enough to be in range, which meant Stegosaurus had to hold its ground rather than flee. This was a gamble, because if the predator anticipated the swing or managed to dodge, it could lunge for the hindquarters or flank. The key to survival was timing, holding the tail low and ready, then unleashing it only when the enemy committed to an attack. The spikes themselves were not all identical. Fossil evidence suggests they varied slightly in shape and length, perhaps as a natural result of growth or injury. Some might have been straighter, others more curved. A broken spike could regrow to a degree, though not to its full original form, leaving a shortened but still functional weapon. In life, the spikes were sheathed in a layer of keratin, just like the plates, which would have kept them razor-sharp at the tips. While defense against predators is the most obvious function of the Thagomizer, some paleontologists have suggested it might also have played a role in intraspecific combat, contests between Stegosaurus individuals. Modern animals with similar weapons, such as antelopes or lizards with spiny tails, sometimes use them in ritualized displays or non-lethal sparring. Two stegosaurs might have swung their tails in wide arcs, testing each other's reactions without making contact or delivering controlled strikes to the flank to establish dominance. Such behavior would have reduced the risk of injury while still settling disputes over territory or mates. From a predator's perspective, the Thagomizer made Stegosaurus a dangerous target. While an Allosaurus could overpower smaller prey with a swift ambush, attacking a healthy adult Stegosaurus meant risking severe injury or death. This deterrent effect alone may have been enough to spare many stegosaurs from direct attacks, especially if predators had witnessed or experienced the damage those spikes could inflict. The presence of such a weapon could shift the balance of an ecosystem, influencing predator behavior and feeding patterns. And yet, the Thagomizer was not invincible. An attack from the front or side, especially if the predator could avoid the tail's arc, still posed a serious threat. Juveniles lacked the full size and reach of an adult's spikes, making them more vulnerable. A sick or injured Stegosaurus might not have had the strength or coordination to swing its tail effectively. In the harsh reality of the Jurassic, even the best defense was not a guarantee. Still, there is something deeply compelling about the image of Stegosaurus standing its ground, tail poised like a living spear rack. In this moment, we see not a slow, lumbering plant eater, but a creature that could, and did, fight back with lethal force. The Thagomizer is a reminder that in the prehistoric world, survival was not only about size or strength, but about having the right tool for the job. As the sun sets over the fern meadows, our Stegosaurus moves into the shelter of the forest, its tail swaying gently behind it. In the dimming light, the spikes catch the last glint of day, a silent warning to anything that might be watching from the shadows. Here, in the quiet of evening, the weapon rests until the next time it is needed. But defense and weaponry are only part of the story. If we wish to understand this creature fully, we must also explore its senses, its brain, and the way it perceived the world around it. For all the power of its plates and spikes, the Stegosaurus was guided through life by its ability to see, hear, and respond to its environment, and by the surprisingly small brain that managed this massive body. In the popular imagination, Stegosaurus has often been painted as a dim-witted creature, a massive, armored body driven by a brain no bigger than a walnut. This image, while rooted in outdated science, has lingered for decades. But to truly understand the Stegosaurus, we must set aside these old caricatures and explore the reality of its senses, its nervous system, and the mind that guided it through the challenges of the late Jurassic world. The myth of the walnut brain originates from early fossil studies, when paleontologists examined the cavity inside the skull where the brain once rested. Compared to the dinosaur's immense body, the space for the brain seemed astonishingly small, roughly the size of a lime, in an animal over 25 feet long. This disparity was taken as a sign of extreme stupidity, and the Stegosaurus became a sort of punchline in prehistoric lore. But brain size alone is not an absolute measure of intelligence. Many modern reptiles, for example, have brains proportionally as small or smaller than Stegosaurus, yet they live complex, successful lives in their environments. To survive for millions of years, the Stegosaurus's brain had to be well suited to its needs. This was not a creature that needed to solve puzzles or craft tools. Its priorities were feeding, mating, avoiding predators, and navigating its environment. Evolution gave it the sensory and neural capabilities to do these things effectively, even if they did not translate to intelligence in a human sense. One of its most important senses was vision. The Stegosaurus's eyes were positioned on the sides of its narrow skull, granting it a wide field of view. This placement is typical of herbivores, allowing them to scan for danger while grazing. While it may not have had the acute depth perception of a predator, its vision would have been excellent for detecting motion, a crucial ability in a world where an Allosaurus could emerge from the tree line at any moment. The wide-set eyes also meant that much of the area directly in front of the head overlapped in binocular vision, giving it some degree of depth perception for foraging. The exact sharpness of Stegosaurus's vision is harder to determine, but comparisons with modern reptiles and birds suggest it could distinguish shapes, patterns, and perhaps even colors. If its plates were indeed used for display, the ability to perceive color would have been advantageous, allowing it to recognize mates or rivals by the vibrancy of their plates. Some paleontologists speculate that dinosaurs may have had vision at least as good as many modern birds, which can see into the ultraviolet spectrum, though this remains unproven for Stegosaurus specifically. Hearing was likely less refined than vision, but still functional. The Stegosaurus's ear structure suggests it could pick up low to mid-range frequencies. Similar to many reptiles today, this would have allowed it to detect the calls of other dinosaurs, the movement of large predators, or environmental sounds like rustling vegetation. The possibility exists that it communicated with others of its kind using low-frequency sounds, rumbles, hisses, or body movements, though no direct evidence of such behavior has yet been found. Its sense of smell may have been moderate, not as developed as in some predators, but sufficient for identifying plants, detecting the presence of other dinosaurs, and sensing danger. The nasal openings were relatively large, and the olfactory region of the brain, while not enormous, was present and functional. A good sense of smell would have been particularly useful in dense forests where visibility was limited, and in tracking the scent of fresh plant growth after seasonal rains. Touch is a more speculative sense in Stegosaurus, but the distribution of nerves in its tail and along its body suggests it was sensitive to contact. The skin, likely covered in small pebbly scales, may have had regions more sensitive than others, perhaps along the flanks or around the base of the plates. The tail, being both a weapon and a critical balancing structure, would have required precise sensory feedback to control its movement effectively in combat. And then there is the most curious aspect of Stegosaurus's nervous system, the so-called second brain myth. Early paleontologists noted a large cavity in the sacral region of the spinal cord, located over the hips. This cavity was much larger than the brain case in the skull, leading to speculation that Stegosaurus had a second brain here to help control its massive body. Some even imagined it as a kind of reflex center, coordinating the movement of the hind legs and tail. Modern science has debunked this idea. The sacral cavity was not a brain at all, but likely housed a glycogen body, a structure found in modern birds that stores energy-rich glycogen. Its exact purpose is still debated, but it may have played a role in supporting the nervous system or providing metabolic reserves. The myth of the second brain persists in popular culture, but the reality is that Stegosaurus's true brain was entirely located in its head, just like ours. Even without a second brain, the Stegosaurus was more than capable of managing its daily life. Its nervous system coordinated the slow but deliberate movements of its legs, the balance of its body, and the complex, powerful swings of its tail. Reflexes would have been crucial in defensive situations. A sudden movement detected by the eyes or skin could trigger a tail strike before the conscious mind had fully processed the danger. The combination of senses, reflexes, and instinct formed a system finely tuned for survival in the late Jurassic. The Stegosaurus did not need to outthink its predators. It needed only to detect them early enough to act, position itself defensively, and use its thagomizer when necessary. In this, its brain was perfectly adequate for the task. In moments of calm, those same senses allowed it to navigate the world with quiet efficiency. It could find the most nutrient-rich patches of ferns, recognize familiar pathways to water sources, and avoid areas frequented by predators. It could identify members of its own species, whether from visual cues, scent, or the sounds they made as they moved through the landscape. It is easy to underestimate animals with small brains, but size is not the sole measure of capability. The Stegosaurus's mind was a product of millions of years of evolutionary refinement, honed to match its body and environment. If we could observe one in life, we would not see confusion or dullness in its eyes. We would see alertness, caution, and a constant assessment of its surroundings. And so, the Stegosaurus's senses and mind were not flawed remnants of a primitive past, but the very tools that allowed it to thrive among the giants of the Jurassic. From here, our journey takes us beyond the daily life of a single individual, to consider a broader picture how these great animals may have moved across the land, following the changing seasons and the ebb and flow of food and water. In the stillness of a late Jurassic morning, the world may have seemed peaceful. The air hung heavy with the smell of damp ferns, the ground soft with the decay of centuries of plant matter, and the sun poured molten gold over the horizon. But for the Stegosaurus, life was never entirely still. The changing seasons, shifts in rainfall, and the endless hunger of its herbivorous body would have compelled movement. We cannot know for certain if Stegosaurus undertook long-distance migrations as many modern herbivores do, but the evidence and ecological reasoning suggest it is possible, even likely. The sheer size of the animal meant that it needed a vast amount of plant matter every single day. In a fertile fern meadow after a period of rain, food might be abundant enough to feed an entire group for weeks. But as the season shifted, as the rains moved on or the soil dried and cracked, those meadows could wither. The cycads might hold their greenery for longer, and the conifers would keep their needles year-round, but the lush, tender ferns would vanish. The Stegosaurus, like the great elephants and bison of later ages, may have been compelled to follow the green. Imagine a small group of stegosaurs, perhaps a few adults and their near-grown young, standing in a valley they have grazed for weeks. The ground cover is thinner now, the once brimming waterhole is low and muddy, and the air is dry. Somewhere far to the north or west, seasonal rains have fallen, feeding new growth along river corridors and floodplains. The scent of that green, rich life may have been carried on the wind, or perhaps instinct alone urged the animals onward. Slowly they begin to move. The pace would have been steady but unhurried. A Stegosaurus could not gallop across the land like a horse. It moved with measured, deliberate steps. Even so, over days and weeks, that pace could carry it across dozens of miles. The journey itself would have been as much a part of survival as feeding. Along the way, the Stegosaurus would encounter open plains, wooded ridges, and swampy lowlands, each offering its own mix of plants and hazards. In wetter regions, the herds might pass beneath towering stands of conifers, the forest floor carpeted with moss and horsetails. These shaded places offered cooler air during the heat of midday, and a reliable supply of water from the streams that trickled between the roots. In drier stretches, they might walk for hours through expanses of low, tough vegetation, feeding sparingly until they reached the next pocket of abundance. The route of such a migration would not be a straight line. It would bend toward water sources, follow ridges that offered safety from flooding, and skirt areas known to harbor large predator populations. Stegosaurus was not a social herd animal in the sense of tightly coordinated migrations like wildebeest today, but it may have moved in loose groups, each individual keeping within sight of the others. The advantage of such loose associations was not protection in numbers, but the simple fact that many eyes and noses together were better at detecting danger. Predators like Allosaurus would have been acutely aware of these movements. A migrating Stegosaurus was not necessarily a weak one, but the act of moving through unfamiliar territory brought risks. A predator might learn the patterns that every dry season the plant eaters move toward a certain valley and position itself along the route. For this reason, migration may have been timed with changes in vegetation that made the journey less predictable, or with shifts in weather that masked the animal's scent and sound. The young would have faced the greatest challenge, while an adult Stegosaurus's tagomizer could turn away even the most determined predator. A half-grown juvenile lacked the same reach and power. Staying close to the larger adults may have offered some protection, and the group's slower pace would have been set to match the youngest member's endurance. In this way, the migration was not simply a quest for food, but a delicate balancing act between finding resources and keeping the vulnerable alive. The landscape of the late Jurassic would have shaped these journeys. The Morrison Formation, the geological layer in which most Stegosaurus fossils are found, tells us that the environment was a patchwork of floodplains, river systems, and open forests. Seasonal rainfall patterns likely caused rivers to swell and recede, leaving behind rich, green corridors in some months and dusty channels in others. Following these waterways could have been a natural migration route, offering both food and water as well as a relatively easy path through the terrain. Along these river corridors, the Stegosaurus might have encountered other migrating herbivores, herds of Camptosaurus browsing on low shrubs, or the long, sweeping necks of Diplodocus herds passing through on their own feeding cycles. Such meetings could be moments of uneasy tolerance. So long as food was plentiful, the species could feed side by side, but in leaner times, competition could flare, forcing the slower Stegosaurus to move on. The migration would not always end in a single destination. Rather, it might follow a circuit, a slow seasonal path that looped through known feeding grounds, revisited at just the right time for regrowth. In this way, the Stegosaurus would not strip any one area bare, allowing the plants to recover before the herd returned. Over generations, these roots could have become ingrained in the species' behavior, passed down not by teaching but by instinct. The return journey, months later, might carry the Stegosaurus back through valleys transformed by the rains. The dry, cracked soil of the previous season could now be hidden beneath a carpet of young ferns, the air rich with their green scent. Streams that had been reduced to muddy trickles would be full again, their surfaces dappled with sunlight and drifting leaves. For a Stegosaurus, the success of a migration was measured not in the number of miles traveled, but in the abundance waiting at the end. Migration also played a role in shaping the land itself. By moving from place to place, Stegosaurus prevented overgrazing in any single location, allowing plant communities to remain healthy and diverse. Their movement spread plant spores and seeds, carried in their droppings or stuck to their rough skin, helping to maintain the mix of vegetation across their range. Even their footprints, pressed deep into the soil, could create small depressions that collected water after rain, serving as tiny oases for other creatures. The cycles of migration would have been as old as the species itself, tied to the rhythms of climate and vegetation that changed little for millions of years. It was a slow, patient dance with the land, one that ensured survival not just for the Stegosaurus, but for the many other creatures that shared its world. As the group reached the end of its seasonal journey, the tension of travel would ease, the pace would slow, the animals spreading out to feed in the most fertile areas. Here they would remain until the signs of change returned, the first hint of dryness in the air, the taste of dust on the wind, the ferns growing pale and brittle, and then, once again, the long walk would begin. To watch such a migration in life would have been to witness a living current of history, a reminder that survival in the Jurassic was not only about the moment-to-moment struggle, but about reading the patterns of the land and following them faithfully. From these great journeys across the ancient landscape, our story now turns to what happened when these magnificent creatures finally fell silent. How the bones of a Stegosaurus once carried on such travels could be preserved for millions of years, waiting in the earth for a new set of eyes to discover them. The Stegosaurus we picture today, with its great arching back plates, its low head, and its spiked tail, is the result of an extraordinary chain of events that began not with its life, but with its death. Fossils are more than mere bones locked in stone. They are the survivors of a journey through deep time, a journey so improbable that for each Stegosaurus that once walked the Jurassic Earth, there are countless others whose remains vanished without a trace. The process begins at the moment of death. A Stegosaurus might have fallen to a predator's attack, succumbed to disease, become trapped in deep mud, or simply collapsed from age and exhaustion. Whatever the cause, the end would set in motion a delicate race between destruction and preservation. In the wilds of the late Jurassic, scavengers were never far away. Small theropods, opportunistic predators, and even large carnivores like Allosaurus could descend upon a carcass within hours. Insects and other invertebrates would quickly join in, stripping away flesh and sinew. This was the first and most likely outcome for any dead animal, total recycling back into the ecosystem. For fossilization to begin, the remains had to escape this cycle, at least partially. The most favorable conditions for preservation came when the carcass was rapidly buried. A sudden flood on a riverbank, the collapse of a muddy slope, or the buildup of sediment in a low-lying marsh could cover a Stegosaurus's remains before scavengers and weather could destroy them. In such a moment, silt and sand would entomb the bones, sealing them from most forms of decay. The faster the burial, the greater the chance that a complete skeleton might survive. Once buried, the long work of fossilization began. Over thousands, then millions of years, water-rich in minerals seeped through the sediments. The organic material in the bones slowly leached away, replaced molecule by molecule with silica, calcite, or other minerals from the surrounding rock. This process, known as permineralization, transformed fragile bone into durable stone, preserving even fine details such as the texture of the bone surface or the tiny openings where blood vessels once passed. In some cases, impressions of skin, scales, or even the plates themselves might be preserved if they were buried under the right conditions, fine-grained sediment that captured their outline before they decayed. These soft-tissue fossils are rare treasures, offering glimpses into the external appearance of animals long gone. In the case of Stegosaurus, no complete skin impressions of the plates have been found, leaving open questions about their color and texture. Time would not stand still for the buried bones. Geological forces pressed down on the sediments, compacting them into solid rock. Tectonic movements could tilt, fold, or fracture the layers, sometimes lifting them from deep burial back toward the surface. Erosion, the slow grinding of wind, water, and ice, would then wear away at the overlying material, gradually revealing the fossilized remains to the open air. This exposure could take millions of years and would eventually doom the fossil to weathering and destruction if it was not discovered. It is here, at the moment when a fossil is once again at the mercy of the elements, that human history enters the story. For most of the time since its burial, The Stegosaurus fossil lay in darkness, unseen and unknown. But in the late 19th century, the growing science of paleontology and the intense competition between collectors in what came to be known as the Bone Wars brought the first Stegosaurus bones to light. Before we reach that chapter of discovery, it is worth pausing to consider the rarity of what was found. For every Stegosaurus fossil uncovered, there may have been thousands of others whose remains were lost forever. A perfect skeleton is even rarer, as weathering, scavenging, and shifting sediments can scatter and destroy bones over time. Many of the Stegosaurus specimens we know today are partial. A leg here, a tail there, sometimes a few plates and spikes without the rest of the skeleton. These fragments are pieced together with painstaking care to recreate the whole animal. The Morrison Formation of Western North America, where most Stegosaurus fossils have been found, is a vast, layered archive of the late Jurassic. Here, ancient floodplains and river systems laid down the sediments that became the rock we see today. Embedded within it are the remains not only of Stegosaurus but of the entire ecosystem: sauropods like Apatosaurus and Diplodocus, predators like Allosaurus and Ceratosaurus, smaller herbivores, turtles, crocodile relatives, and the plants that sustained them all. Each fossil from the Morrison is a page in a story that took millions of years to write. When paleontologists uncover a Stegosaurus fossil, they are not simply pulling bones from the ground, they are excavating the final resting place of an animal that walked the earth 150 million years ago. The process is slow and meticulous. First, the surrounding rock must be removed with picks, chisels, and brushes, careful not to damage the fossil within. As more of the bone is revealed, it is stabilized with special glues and wrapped in protective layers of plaster and burlap before being transported to a laboratory. In the lab, the work continues under magnification. Dirt and rock are cleaned from every crevice, repairs are made to fractures, and the fossil is studied in detail. Measurements, photographs, and scans are taken to record every aspect of its form. From these data, scientists can reconstruct not only the anatomy of the Stegosaurus, but aspects of its life, its age at death, evidence of injuries or disease, and perhaps even its cause of death. Sometimes the fossil record tells a dramatic tale. A healed puncture wound in a plate might hint at a battle with a predator. A fused joint could suggest arthritis in an older individual. A cluster of bones from multiple stegosaurs in the same layer might point to a group dying together, perhaps in a flood or drought. These stories are built from fragments, but they offer a connection across an unfathomable gulf of time. Yet, as remarkable as these fossils are, they are incomplete. Bone can tell us much about structure, but little about color, behavior, or the sound of a living Stegosaurus's footsteps. The fossil record is a foundation, but the living animal exists now only in the realm of informed imagination. Still, the fact that we can stand before a set of Stegosaurus plates or see the very spikes that once swung in defense against an Allosaurus is nothing short of miraculous. The making of a fossil is a story of luck, timing, and patience on a scale far beyond human experience. From death and burial, through the slow transformation into stone, to the moment of rediscovery, each step is a reminder of how much the past still lies hidden beneath our feet. And so, from the earth that cradled these remains for millions of years, we move forward in time to the moment when the first scientists laid eyes on them. The age of discovery, rivalry, and revelation that brought Stegosaurus from obscurity into the light of human knowledge. The story of Stegosaurus's discovery is woven into one of the most colorful, competitive, and sometimes chaotic chapters in the history of science. The late 19th century fossil rush known as the Bone Wars. This was not merely a period of paleontological exploration. It was an era defined by personal rivalry, fierce ambition, and an almost feverish race to claim the glory of naming new prehistoric giants. The Bone Wars were centered around two men, Othniel Charles Marsh and Edward Drinker Cope. Both were brilliant, both were determined, and both were utterly unwilling to be outdone by the other. their rivalry would drive unprecedented fossil hunting efforts across the American West in the 1870s and 1880s, leading to the discovery of dozens of new dinosaur species, but it also bred a climate of secrecy, haste, and at times questionable scientific practices. It was in this high-stakes atmosphere that Stegosaurus first came to light. The year was 1877, and in the rugged landscapes of Colorado, near the town of Morrison, fossil hunters working for Marsh uncovered a set of strange, massive bones. Among them were flat, plate-like structures unlike anything seen before, along with limb bones, vertebrae, and a spiked tail. Marsh recognized that this was something entirely new to science. In 1877, he formally named the creature Stegosaurus armatus, the roofed lizard, based on his belief that the plates lay flat along the back like shingles on a roof. This initial interpretation was understandable. The fossil evidence was incomplete, and the arrangement of the plates in life was not yet known. In fact, early reconstructions of Stegosaurus looked very different from the animal we recognize today. Marsh's first skeletal mount depicted a low-slung creature with its plates lying flush against its skin, as though it were armored like a turtle. It would take decades, and many more fossil discoveries to correct this image. The discovery site in Morrison was part of what is now known as the Morrison Formation, a geological layer stretching across several states, rich in late Jurassic fossils. In the late 19th century, this region became a battleground for Cope's and Marsh's fossil hunting crews. Expeditions worked under intense pressure, racing to extract fossils before their rivals could claim the same site. Camps were set up in remote valleys, supplies hauled in by wagon, and workers toiled under harsh sun and sudden storms, their eyes always on the lookout for the telltale glint of bone in the rock. The competition between Marsh and Cope was so fierce that it sometimes bordered on sabotage. There are stories, some confirmed, others perhaps exaggerated, of crews dynamiting fossil beds to prevent the other from excavating them, or of mislabeling crates in transit to mislead the competition. In such an atmosphere, the focus was often on speed rather than careful study, and some specimens suffered damage in the rush to remove them. Still, the sheer volume of fossils collected during this period was staggering, and many of them, including the first Stegosaurus bones, became the foundation for modern paleontology. Marsh's Stegosaurus specimens generated considerable excitement. Not only were the plates unlike anything in other known dinosaurs, but the combination of the small skull, long hind legs, and spiked tail was unlike anything in the fossil record. Newspapers of the day picked up on the discovery, adding to the public fascination with the antediluvian monsters emerging from the rocks of the West. Over the next few years, more Stegosaurus fossils were found in Colorado and Wyoming, gradually filling in the gaps in its anatomy. As the evidence grew, so did the realization that Marsh's initial roofed lizard interpretation was wrong. By the late 1880s, paleontologists began to suspect that the plates stood upright along the back, perhaps in a single row. Even this would later prove incomplete, as further finds showed that the plates were arranged in two alternating rows, giving the dinosaur its distinctive silhouette. The bone wars may have been marked by rivalry and recklessness, but they also sparked a surge in public interest in prehistoric life. Museums in the eastern United States began to mount dinosaur skeletons, drawing crowds eager to see the ancient giants for themselves. Stegosaurus became one of the most recognizable members of this growing menagerie, its strange form capturing imaginations and inspiring speculation about its lifestyle. For Marsh, the naming of Stegosaurus was a personal victory in his ongoing duel with Cope, but the rivalry's toll was heavy. Both men spent fortunes on their fossil hunts, and both saw their reputations suffer in the scientific community for the sometimes questionable methods they employed. By the time the bone wars wound down in the 1890s, Marsh and Cope had collectively named over 100 new dinosaur species, some valid, others later determined to be duplicates or misinterpretations. Stegosaurus, however, remained one of the lasting and legitimate stars of their work. It is worth remembering that in the 1870s and 1880s, paleontology was still a young science. The idea of deep time, that Earth's history stretched back millions of years, was only just gaining widespread acceptance. Dinosaurs were known from scattered bones and teeth, often poorly understood. The discovery of a nearly complete Stegosaurus skeleton was a revelation, offering a rare glimpse into the life of an animal that had walked the Earth 150 million years earlier. In the decades following its discovery, Stegosaurus would be reinterpreted many times. Early reconstructions gave it more plates than it actually had, or placed the plates in symmetrical pairs. At one point, scientists even speculated that the plates might have been embedded in the skin horizontally, serving as armor rather than display structures. Gradually, careful study of better preserved specimens corrected these errors, leading to the image we know today, a slow-moving, plant-eating giant with two staggered rows of upright plates and a formidable spiked tail. The name Stegosaurus has since become almost synonymous with the age of dinosaurs, appearing in textbooks, documentaries, and museum halls around the world. Its discovery during the height of the Bone Wars ensured it a place not only in paleontological history, but in the broader story of scientific rivalry, exploration, and the race to understand our planet's distant past. From the dusty hills of Morrison, Colorado, to the polished floors of great museums, the journey of Stegosaurus from stone to skeleton was only the first step in its scientific story. As the 20th century dawned, new finds and new technologies would begin to transform our understanding of this strange and iconic dinosaur, pushing it beyond the initial sketches of the Bone Wars into a fuller, richer portrait. And so, from the chaos and competition of its discovery, we move into a calmer, more methodical era, one in which the focus shifts from naming and claiming to studying and understanding, revealing how our picture of Stegosaurus has evolved over time. The Stegosaurus that lives in our minds today, with its proud, alternating backplates and its tail bristling with spikes, is the result of over a century of refinement in scientific knowledge. Its image has shifted dramatically since those first fossilized plates were unearthed in Colorado in 1877, and each new discovery, each fresh study, has chipped away at the errors of the past while deepening our appreciation for this peculiar and beautiful dinosaur. When Othniel Charles Marsh first described Stegosaurus, his reconstruction was unlike the one we know now. He imagined the plates lying flat like shingles, forming an armored shield along the dinosaur's back. In his mind, this was the logical placement for such structures: defensive armor, a roof for the roofed lizard. The tail spikes were included, but the posture was different, low to the ground, with the legs splayed somewhat like those of a lizard. This early interpretation gave Stegosaurus a squat, reptilian appearance that lacked the imposing elegance we now associate with it. It did not take long for other scientists to question this vision. As more complete fossils were uncovered, some with plates still loosely in position, it became clear that the plates were not flat and horizontal but upright. Initially, they were thought to be paired in symmetrical rows running from neck to tail. The dinosaur was still imagined as somewhat lizard-like in stance, but this was the beginning of a slow pivot toward a truer form. The first mounted skeletons of Stegosaurus in museums during the late 19th and early 20th centuries captured public attention, but they were far from perfect. The plates were often reconstructed too numerous, their arrangement guesswork at best. The tail spikes, while correctly placed at the rear, were sometimes angled oddly or given unrealistic curvature. Without modern reference points, paleontologists were doing their best to make sense of an animal unlike anything alive today. The early to mid-20th century brought gradual changes. The discovery of more complete specimens in places like Wyoming and Utah allowed scientists to confirm that the plates were not paired, but arranged in two alternating rows along the back. This arrangement was stranger, but also far more visually striking, giving Stegosaurus its now iconic silhouette. The posture also began to change. The legs, once imagined as sprawling, were recognized as being held more vertically beneath the body, supporting a slow but steady gait. One of the most significant shifts in understanding came with a closer look at the tail. For decades, the spikes were thought to be mainly ornamental, or, at best, of limited defensive use. But in the late 20th century, paleontologists began to study evidence from damaged predator bones, puncture wounds that matched the size and shape of Stegosaurus spikes. These findings confirmed what the anatomy had long suggested. The thagomizer was a deadly weapon, capable of crippling or killing an attacking predator like Allosaurus. The plates themselves also underwent a re-evaluation. While early interpretations saw them as armor, detailed studies of their structure revealed an intricate network of blood vessels. This prompted the thermoregulation hypothesis, that the plates acted as radiators, releasing excess body heat or absorbing warmth from the sun. Later still, many paleontologists began to view them primarily as display structures, used for species recognition, mate attraction, or intimidation. Today, most scientists agree they likely served multiple functions, combining thermoregulation with social signaling. Our understanding of Stegosaurus's behavior also evolved alongside these anatomical revelations. Once thought to be a solitary, slow-witted creature, it is now often envisioned as living in small groups, its senses tuned to detecting predators, and its life shaped by seasonal movements in search of food. The dumb dinosaur stereotype, fueled by the small size of its brain relative to its body, has been dismantled by the realization that brain size does not necessarily indicate survival capability. Stegosaurus's neural processing was perfectly adequate for its needs. Technology has played a major role in refining our image of Stegosaurus. CT scans of fossilized bones have allowed researchers to examine internal structures without damaging specimens. Computer modeling has helped reconstruct muscle placement, movement range, and even potential striking speed of the tail. Digital reconstructions have brought to life the way the plates may have looked in color, with speculation ranging from earthy browns to vivid reds and oranges. Paleohistology, the study of fossil bone microstructure, has revealed growth patterns in Stegosaurus. By examining thin slices of bone under a microscope, scientists can identify growth rings, much like those in trees, to estimate the age of an individual at death. These studies suggest that Stegosaurus grew relatively quickly in its early years, reaching near adult size in a decade or so before slowing as it matured. Such insights give us a sense of its life cycle in a way Marsh and his contemporaries could never have imagined. Even the classification of Stegosaurus has been refined over time. It belongs to the family Stegosauridae, a group of plated, herbivorous dinosaurs within the larger clade Thyreophora, which also includes armored dinosaurs like ankylosaurs. Within this family, Stegosaurus is recognized as the largest and most famous representative, but related species from around the world have broadened our understanding of what stegosaurs could be. Comparing Stegosaurus to its relatives has shed light on why its plates became so large, and why its overall body proportions took the shape they did. Public perception has followed these scientific shifts. The Stegosaurus of early museum halls, short, low, heavily armored, gave way to the more upright, strikingly plated creature we know today. In films, books, and documentaries, it has shifted from a passive, lumbering background presence to an active participant in the prehistoric drama, capable of defending itself with surprising ferocity. Modern paleo art often depicts it bathed in golden Jurassic light, plates catching the sun, tail poised like a warning to any who might threaten it. The changes in our understanding of Stegosaurus are a testament to the evolving nature of science itself. Each new fossil find, each technological advance has refined the picture, replacing guesswork with evidence. The Stegosaurus we imagine now is closer to the truth than it has ever been, yet it remains a work in progress. There are still unanswered questions. What exact colors did its plates display? Did males and females look different? How often did it use its tail in combat? Did it truly migrate, or did it live year-round within a smaller home range? In this way, Stegosaurus stands as a symbol not just of prehistoric life, but of the process of discovery, how our view of the past is shaped, challenged, and reshaped again over time. From Marsh's roofed lizard with flattened plates to today's proud alternating plated giant, Its transformation in our minds mirrors our own growth in knowledge. And yet, Stegosaurus was not alone in the world. Across the continents, other members of its family thrived, each with its own unique armor and adaptations. To fully appreciate Stegosaurus, we must now look outward, comparing it to these global relatives to see the broader story of the plated dinosaurs, a lineage that spanned oceans, climates, and millions of years. Although Stegosaurus is the most famous member of its family, it was far from the only plated dinosaur to roam the Earth. In fact, the stegosaurs were a diverse and widespread lineage, leaving their mark on multiple continents during the Middle and Late Jurassic, and even persisting into the early Cretaceous in some regions. Their shared features, the rows of plates or spikes, the small head, the heavily built body, and the formidable tail weaponry, mark them as kin, but their forms varied in intriguing ways, shaped by different climates, environments, and evolutionary pressures. To appreciate Stegosaurus, we must first place it within the broader family tree. Stegosauridae is part of Thyreophora, the shield bearers, a branch of ornithischian bird-hipped dinosaurs that also includes the ankylosaurs, the club-tailed tanks of the Cretaceous. Within Stegosauridae, we find a variety of genera that, while sharing a core body plan, differ in size, plate arrangement, and defensive adaptations. Our journey begins far from the North American home of Stegosaurus, in the lush floodplains of what is now Tanzania. Here, during the late Jurassic, lived Kentrosaurus. If Stegosaurus was a balanced blend of plates and spikes, Kentrosaurus was a more extreme interpretation. Along the front half of its back, it bore small, narrow plates, but toward the hips and down the tail, these gave way to long, vicious spikes, some extending nearly 5 feet. The tail itself was a fearsome weapon, with spikes that may have been even more dangerous than those of Stegosaurus. Though smaller overall, reaching about 15 feet in length, Kentrosaurus may have been quicker and more agile, darting its tail at predators with precision. Crossing continents, we find ourselves in China, home to Tuajangasaurus. This stegosaur, also from the late Jurassic, is often described as resembling Stegosaurus in body form, but with plates that were lower, narrower, and more closely spaced. Fossils of Tuajangasaurus have been discovered in remarkable condition, allowing scientists to reconstruct its skeleton with great accuracy. Living in the humid, river-laced landscapes of Jurassic Asia, it likely faced predators similar in size and ferocity to Allosaurus, and its plates and tail spikes would have served both as deterrents and display features. Nearby in the fossil record, another Chinese stegosaur, Wuerhosaurus, lived not in the Jurassic but in the early Cretaceous. This makes it one of the youngest known stegosaurs, surviving well after most of its relatives had vanished. The climate of early Cretaceous China was cooler than the Jurassic warmth in which Stegosaurus thrived, and Wuerhosaurus had plates that were smaller and more rounded, perhaps an adaptation to this different environment. Its existence hints that stegosaurs were more adaptable than once thought, capable of surviving shifts in climate and flora that ended the reign of many of their kin. In Europe, stegosaurs took on their own unique forms. Fossils from Portugal have revealed Miragaia, a stegosaur notable for its extraordinarily long neck. Where Stegosaurus had a relatively short neck with around 10 vertebrae, Miragaia had at least 17, giving it a silhouette that seemed almost part sauropod. This adaptation may have allowed it to browse on higher vegetation than other stegosaurs, occupying a feeding niche with less competition. Miragaia's discovery in 2009 challenged long-held assumptions about the limits of stegosaur body design, showing that even within a seemingly specialized lineage, there was room for dramatic variation. The British Isles, too, may have hosted stegosaurs, though the fossil evidence is fragmentary. Isolated plates and spikes from England have been tentatively assigned to the family, suggesting that these dinosaurs had a wider range than the handful of complete skeletons might suggest. In many cases, such fragmentary finds are frustratingly incomplete. A single plate cannot easily tell the story of the animal it came from, but they hint at a diversity of stegosaurs yet to be fully uncovered. If we travel back to North America, we find that Stegosaurus itself was not a single species, but a small genus with several named members. Stegosaurus armatus, the first to be described, is now considered distinct from Stegosaurus stenops, which is known from more complete skeletons. Stegosaurus ungulatus and Stegosaurus sulcatus represent additional variations in plate and spike arrangement. These differences may reflect changes over time, adaptations to different regions within the Morrison Formation, or even variations between males and females. Comparisons between these relatives reveal patterns and puzzles. All stegosaurs share the hallmark small head, long hind legs, and the tail weapon, but the balance between plates and spikes varies. In some, like Kentrosaurus, spikes dominate, suggesting a heavier emphasis on direct defense. In others, like Stegosaurus and Tuajangosaurus, the plates are more pronounced, hinting at a greater role in display or thermoregulation. The variation in plate size, shape, and number may also reflect differing social behaviors or environmental pressures. Geography played a role in shaping these differences. In North America's Morrison Formation, open floodplains dotted with groves of conifers may have favored display structures that could be seen from a distance, making tall plates an advantage. In denser forest environments, like those inhabited by some Asian stegosaurs, lower, narrower plates might have been sufficient, while longer spikes provided a more reliable defense against ambush predators. Climate, too, may have influenced their evolution. The cooler conditions of early Cretaceous Asia could explain the reduced plates of Wuerhosaurus, as large, heat-radiating surfaces may have been less useful in a cooler climate. Conversely, in the warm, often humid environments of the late Jurassic, plates with rich blood supply could have helped regulate body temperature, especially during active feeding in open areas under the sun. Looking across the family, we also see differences in size. While Stegosaurus could reach lengths of around 30 feet and weights exceeding 7,000 pounds, many relatives were smaller, ranging from the 15-foot Kentrosaurus to the 20-foot Tuajangosaurus. These size differences could have shaped not only their feeding strategies, but also their vulnerability to predators. A smaller stegosaur might rely more on agility and a rapid tail strike, while a larger one could stand its ground, relying on its bulk as part of its defense. Despite these variations, stegosaurs as a group shared a remarkable consistency of core design, a testament to the evolutionary success of their body plan. The combination of a heavily built body, protective or display structures along the back, and a formidable tail weapon was clearly effective across different continents and climates. Their global spread in the Jurassic reflects both the connectedness of land masses at the time and the adaptability of their general blueprint. Yet, for all their success, stegosaurs would eventually fade from the fossil record. By the middle of the Cretaceous, they were gone, replaced in many herbivore niches by other ornithischians, including the horned ceratopsians and the duck-billed hadrosaurs. The reasons for their decline remain uncertain. Perhaps changes in climate, vegetation, or predator communities tipped the balance against them. But while their time on Earth ended, their legacy remains in the stones and sediments they left behind, and in the iconic silhouette of their most famous representative. In Stegosaurus, we see the culmination of this lineage's design: large, upright plates for display and thermoregulation, a powerful tail for defense, and a body built for steady, deliberate browsing. Understanding its relatives not only highlights what made Stegosaurus unique, but also places it within a broader narrative of evolution, adaptation, and eventual extinction. From this global perspective, our focus now turns to another realm entirely, not the prehistoric plains and forests where stegosaurs lived, but the human imagination they have inhabited since their discovery. In art, literature, film, and the collective memory of childhood dinosaur fascination, Stegosaurus has taken on a cultural life far beyond its Jurassic origins. Few dinosaurs have captured the public's imagination as vividly as Stegosaurus. While the mighty Tyrannosaurus Rex may rule in ferocity and the towering Brachiosaurus inspires awe with its sheer size, Stegosaurus occupies a unique place, a creature that looks both fearsome and oddly endearing. Its combination of enormous upright plates, fearsome tail spikes, and a small, almost gentle-looking head has made it a favorite in books, films, toys, and museum halls for over a century. The cultural journey of Stegosaurus began not long after its scientific discovery in 1877. The late 19th century was a time of growing public fascination with prehistoric life. Newspapers reported on the dramatic fossil finds of the Bone Wars, describing the creatures in colorful, often exaggerated language. The very shape of Stegosaurus, so unlike any living animal, was perfect for grabbing headlines. Readers were introduced to the roofed lizard, imagined as a slow-moving armored behemoth that roamed alongside other giants of a lost world. In the early 20th century, as museums began to mount dinosaur skeletons for public display, Stegosaurus quickly became a star attraction. Its skeletal form, with the two alternating rows of plates sweeping along its back and the spikes at the end of its tail, was an immediate crowd pleaser. Children stood wide-eyed before the mounts, tracing the line of plates from neck to hips, while adults marveled at its strange beauty. These displays were not merely scientific exhibits, they were cultural events, shaping the way generations of people imagined the prehistoric world. As motion pictures emerged as a popular medium, dinosaurs began to make their way onto the silver screen. One of the earliest notable appearances of Stegosaurus came in the 1933 classic King Kong. In the film, a Stegosaurus is portrayed as an aggressive, dangerous animal, its tail spikes swinging as it charges at the human characters. While the film's portrayal was far from accurate, the animal was faster, more hostile, and less biomechanically realistic than any real Stegosaurus. It cemented the image of the dinosaur as a formidable force. In the decades that followed, Stegosaurus continued to appear in popular culture, often as the archetype of the spiky dinosaur. In children's books and cartoons, it was sometimes portrayed as gentle and herbivorous, a sort of prehistoric, big friendly giant of the dinosaur world. In other works, it was a defensive powerhouse, using its tail to fend off predatory Allosaurus or Ceratosaurus. These differing portrayals reflected the evolving scientific understanding of the animal, but also the flexibility of its image. It could be cast as either gentle or dangerous, depending on the story being told. In the mid-20th century, Stegosaurus became one of the most recognizable dinosaurs in educational materials. Its silhouette, with the distinctive row of plates, appeared in school textbooks, encyclopedias, and science posters. Its form was easy to remember and identify, making it a favorite for teaching children about prehistoric life. Paleontologists and illustrators alike knew that a well-drawn Stegosaurus could spark curiosity, leading young learners to explore deeper into the science of paleontology. This cultural presence grew even stronger in the late 20th century, as the so-called dinosaur renaissance brought renewed public interest in prehistoric life. Advances in paleontology during this period corrected many earlier misconceptions, and popular books and television programs embraced the updated image of Stegosaurus as a more active, dynamic creature. Illustrations depicted it in lush Jurassic landscapes, bathed in golden sunlight, its plates glowing with imagined color as it moved through ferns and cycads. In 1993, the release of Jurassic Park marked a new era for dinosaurs in popular media. Although the first film did not feature Stegosaurus, its sequel, The Lost World, Jurassic Park 1997 brought the dinosaur to life with state-of-the-art animatronics and computer-generated imagery. Audiences watched in awe as a herd of Stegosaurus moved through a misty forest, their plates swaying gently, their tails ready to strike. While these film versions still took creative liberties, they introduced millions to a vision of Stegosaurus that was far more lifelike than earlier portrayals. In video games, Stegosaurus has appeared as both a playable creature and a background inhabitant of prehistoric worlds, from early pixelated versions in 1980s arcade titles to the highly detailed, behavior-rich dinosaurs in modern simulation games like Jurassic World Evolution. The animal's striking appearance has made it a favorite among players. Its easily recognized form translates well into digital environments, allowing players to instantly identify it even at a distance. Toys and models have also played a major role in embedding Stegosaurus in popular culture. From the hard plastic dinosaur figures of the 1950s to the hyper-detailed, scientifically accurate collectibles of today, Stegosaurus has been a staple in toy collections. Its form, with tall plates and a spiky tail, makes it a visually exciting figure, and the contrast between its massive body and tiny head often gives it a slightly whimsical appeal, even when designed for realism. Art has been another avenue through which Stegosaurus has entered the cultural imagination. Paleo-artists have long loved the challenge of reconstructing this dinosaur, experimenting with the colors, textures, and arrangements of its plates. While no one knows exactly what colors Stegosaurus wore in life, artists have explored every possibility: muted browns and greens for camouflage, bright reds and oranges for display, and even iridescent sheens inspired by modern reptiles and birds. These creative interpretations keep the image of Stegosaurus fresh, even for those already familiar with it. Beyond entertainment and education, Stegosaurus has also found its way into symbolic roles. In 1982, it was named the official state fossil of Colorado, recognizing its historical significance and the richness of the Morrison Formation in which it was first discovered. Statues of Stegosaurus stand outside museums, parks, and visitor centers, often serving as friendly mascots inviting people to explore natural history. Even in humor, Stegosaurus plays a part. The informal adoption of the term thagomizer for its tail spikes, coined in a Gary Larson Far Side cartoon, is a rare example of a joke becoming semi-official scientific slang. Many museum placards and paleontology lectures now use the term, a light-hearted nod to the dinosaur's cultural life beyond strict science. What is perhaps most striking about Stegosaurus in culture is its adaptability. It can be reimagined endlessly. A gentle grazer in a children's story, a fierce defender in an action movie, a symbol of prehistoric mystery and fine art, yet it remains unmistakable. The plates, the tail, the small head, together they form a visual signature that has endured for nearly 150 years since the animal's discovery. This enduring popularity ensures that Stegosaurus will remain a fixture in the human imagination, whether in the halls of a museum, on the screen in a blockbuster film, or printed in the pages of a child's first dinosaur book. It continues to invite curiosity, and with each new scientific discovery, the cultural image shifts slightly, blending fact and creativity into an ever-evolving portrait. From its life in the Jurassic to its place in 21st century media, Stegosaurus has crossed a gulf of time that is almost impossible to comprehend. And yet, as beloved as it is in art and storytelling, its greatest legacy lies in what it teaches us about evolution, adaptation, and the mysteries that still linger in the fossil record. From here, our journey moves toward the final reflection on the Stegosaurus's lasting legacy, not just as a fossil or a museum display, but as an enduring symbol of prehistoric life itself. The Stegosaurus, though long extinct, has left footprints far deeper than any it pressed into the soft Jurassic soil. Its legacy is written not only in the stone of the Morrison Formation, but in the pages of science, the walls of museums, and the imaginations of generations who have stood before its towering plates and spiked tail. It is a creature whose story bridges the chasm between ancient Earth and modern thought, reminding us that the past is not simply gone, but continues to shape our understanding of life and our place within it. In paleontology, Stegosaurus stands as a benchmark, a species that has been studied for well over a century, with each generation of scientists peeling back another layer of mystery. Its initial discovery during the frenetic era of the Bone Wars represented both the promise and the pitfalls of early fossil science. Those first misinterpretations, plates imagined as armor lying flat, the creature thought to move like a sprawling reptile, are today held up as examples of how scientific understanding evolves. This in itself is part of Stegosaurus's legacy. It is a case study in the self-correcting nature of science. For paleontologists, Stegosaurus also embodies the importance of incomplete evidence. Very few complete skeletons have been found, and yet from scattered bones, partial plate arrangements, and careful comparisons with relatives, a vivid portrait has emerged. This reconstruction has required collaboration between fieldwork, laboratory analysis, biomechanics, and comparative anatomy. The process mirrors the broader work of paleontology, piecing together entire worlds from fragments and learning to be humble in the face of what we do not yet know. Its legacy also lies in the questions it still provokes. Were the plates truly used for thermoregulation, or were they primarily for display? Did they flush with blood during mating season, creating a living flag of color against the green Jurassic landscape? How often did Stegosaurus wield its thagomizer in combat? Were its migrations as vast as those of modern elephants, or did it live within a smaller home range, browsing in familiar valleys? These questions keep the animal alive in the minds of scientists, ensuring it remains a subject of active research rather than a static relic. In the public sphere, Stegosaurus has become a gateway to paleontology. Its instantly recognizable silhouette draws children to museum halls, where they encounter the broader story of life on Earth. Many paleontologists have traced their fascination with the subject back to a childhood moment when they first saw the towering plates and spikes in person or on a page. In this way, Stegosaurus has helped seed new generations of scientists, artists, and enthusiasts, extending its influence far beyond the confines of the Jurassic period. Its symbolic power is also deeply rooted in its contrast of form. Here is an animal that looks, at first glance, almost contradictory. A gentle plant-eater equipped with the arsenal of a warrior, a massive body balanced on stout legs, topped by a small, almost delicate head. The duality, strength and vulnerability, beauty and danger, invites reflection. In nature, these qualities are not opposites, but parts of the same survival strategy. For those who encounter Stegosaurus, even outside a scientific context, this juxtaposition resonates on a deeper level. The Stegosaurus legacy is not confined to the halls of academia or the hearts of enthusiasts. It is woven into cultural memory. Statues greet visitors at museum entrances. Its likeness appears in state symbols, such as Colorado's designation of Stegosaurus as its official state fossil. Its form has been reproduced endlessly in toys, books, and films. These representations, while often stylized or simplified, keep the animal present in everyday life, allowing even those with little knowledge of paleontology to recognize it instantly. In recent decades, advances in technology have allowed Stegosaurus to re-emerge in even greater detail. Three-dimensional scanning, digital modeling, and biomechanical simulations have not only refined our understanding of how it moved and fought, but have also allowed people around the world to explore virtual reconstructions of its habitat. In this way, the legacy of Stegosaurus is no longer confined to those who can stand before its fossilized remains. It has gone global, accessible to anyone with a screen. And yet, its most profound legacy may be the reminder it offers about the vastness of time and the resilience of life. Stegosaurus lived in an era unimaginably distant from our own, over 150 million years ago. The continents were in different positions. The plants it ate have either evolved beyond recognition or vanished entirely. The predators it faced have been gone for eons. And yet, here we are, able to reconstruct its form, its world, and even in part, its behavior. That we can do so is a testament to the durability of the fossil record and to humanity's determination to understand the deep past. It also reminds us of the fragility of species. The stegosaurs as a group were successful for millions of years, spreading across continents and diversifying into many forms. But like so many lineages, they eventually disappeared, leaving no descendants. Their extinction was not a failure, but part of the natural ebb and flow of life through geological time. The legacy they leave, in stone, in science, in story, is a quiet testament that nothing lasts forever, and that survival is always contingent on a changing world. For all its scientific and cultural weight, Stegosaurus remains, for many, a creature of wonder. To stand in its imagined presence is to be reminded that the earth we walk upon has hosted forms of life, stranger, grander, and more varied than we can easily conceive. Its plates rise like sails into the golden light of the Jurassic dawn. Its tail, armed with spikes, swings gently as it moves through a meadow of ferns. The air hums with the sound of ancient insects, and somewhere in the distance the low call of a sauropod rolls across the land. That image, part science, part imagination, is itself part of the dinosaur's legacy. It lives not only in the fossil bed and the scientific paper, but in the quiet visions it sparks in each of us. Long after we have left the museum, long after we have closed the book or turned off the screen, the Stegosaurus lingers, a symbol of a world that once was and will never be again, and a reminder that the traces of that world are still with us, waiting to be uncovered, studied, and shared. And so, our long walk alongside this remarkable creature draws to a close. From the first glimpse in the Jurassic mists to its enduring presence in our modern age, the Stegosaurus has shown us what it means to endure in memory, if not in flesh. It remains both a chapter in Earth's history and an emblem of our curiosity, a bridge between the deep past and the minds that seek to know it. Our journey with Stegosaurus has taken us from its discovery in the heat of the Bone Wars to the living, breathing animal that roamed the Jurassic plains. We've seen how science reshaped our understanding, from a low, shingle-plated reptile to a proud, upright giant with striking plates and a deadly tail. We've traced its place among global relatives, its deep cultural impact, and the enduring mysteries it still holds. More than just a fossil, Stegosaurus has become a bridge between past and present, a reminder of evolution's creativity and the fleeting nature of every species' time on Earth. It endures in our minds because it is both alien and familiar, peaceful and powerful, strange yet beautiful. And so we leave it in its own world, standing in the golden light of a Jurassic sunset, plates catching the last warmth of the day, tail at rest, the land around it quiet. Good night, Stegosaurus. Good night, Jurassic World, and good night to you, the viewer.